So good morning to all. Welcome to Image Graphics Wednesday webinar. My name is Fauzan and I am a technical engineer in image graphics. For your information, all the attendees are muted by default. If you have any questions, please type the questions in the question tab or you can raise your hand, which is already there in your list actually. Okay. So our today's topic is what's new in PVLE 2016. So we'll be discussing about the new features which has been updated in the newer version. Okay, so these are the following points which we are going to cover in today's webinar. So we'll be discussing about the productivity enhancements, the graphics has been updated and some new features has been added. So we'll be discussing about that. Then there is a mandatory code update. Then interfacing and analysis has been, few bugs were there which has been fixed in this version, and few new interfaces has been updated. Then they have updated the output report. So output generation, you can customize, some things can be possible. So we'll be discussing about all these points. So let's discuss about the first point, that is the productivity enhancements. So coming to the first point, that is the nozzle input. So now they have made the entry of nozzle dimensions from the center line of the cones. So if you are aware, this is mainly for the conical section which is attached to the shell. Okay, so most of the times what happens, that customer gives the dimension basically from the center line of the cone. So if you know the center line distance, then you can directly give all the values and you can prompt it. So what PVLit will do it, PVLit will compute the distance from the weld line if you give the offset. So this will help you a lot actually. Earlier we used to find out, we used to have the center line for cone dimension, and we used to convert those values, and then we used to enter it into the from node value. But with the help of this distance, PVLit will automatically compute the distance which is from the weld line, and when you provide the offset. Okay, so this was the first productivity. Let's move on to the second point. So this was again a very good feature they introduced in this version of the software, that is the appendix 2 calculated flange on the end of the nozzle. So what we are doing it over here is like, now we can model a standard flange or a non-standard flange to that nozzle neck actually. So in the earlier version, when we used to model a nozzle, and whatever the information which we used to provide it, that the flange is a well neck flange or a different type of flanges, that time the assembly looks to be the same only, and PVLit was not doing the appendix 2 calculation for the flanges which is on the nozzle actually. So now it is possible, now you can model a flange to that nozzle, but there is some tricky way, the way you can model it actually. You might have modeled the sump head in the earlier version, used to model it earlier. The same procedure, you have to model that flange. So when we used to model a sump head, so what we used to do, we used to go to the last element, we used to attach the elliptical dish, then we used to click on the sump head, we used to check this box, then we used to connect it to the parent nozzle where you are going to connect it. So this is the same way we are going to attach the appendix to flange. So this I will be showing it to you once I am completing with the PPT presentation, then we will open the software and we will discuss on how to model those things. Okay, so let's move on to the next. So now you can model a mating flange which is connected to the well neck flange or a blind flange. So this also can be possible now in this version. So the modeling procedure is the same. The way you are going to model a well neck flange, in the same procedure, we will be going to model a blind flange. Then the next is, now you can model nozzle on the blind flange. So in the earlier version, when we used to model a nozzle with the blind flange, I mean, we were not able to attach the nozzle onto that because PVL it do some modeling based on the node numbers. So when we used to attach a flange to the nozzle, so flange was not having a node number in that in the earlier version. That is the reason we never used to the modeling of the nozzle to that blind flange was not possible. But now, since the procedure has been made for the appendix 2 flange, now you can model the nozzles onto that blind flange also. So the same we will be I will be showing it to you later on. Then the next productivity, this is again a very good enhancement they have made it, that now you can able to see the repad graphics in your 3D model. So you can see the nozzle repad, and so all the graphics are clear to you now. So with the help of this, you can come to know the this is the area for the nozzle. So the clashing of the nozzle can be easily checked out from by this actually. Okay. Then moving on to the next enhancement, that is the element edges has been displayed. Now, if you see, when we used to model a tall tower, though we are modeling it in with number of courses, but when we used to see in the 3D model, it was just like a single cylinder actually. But now they have made this displayed that now you can able to see the circumferential weld line. You can see the circumferential weld line over here. So now with the help of this, I can come to know that this is my cylinder 1 and this is my cylinder 2. Okay. So currently they have introduced the circumferential weld line. In the future, they will be going to add the longitudinal weld line also will be visible to you in the next version. Same thing over here, you can see the repad graphics, the curve, everything is clear to you now, and the edges mainly. So the edges are also clear now. Then the next productivity is the expansion joint graphics. They have improved the expansion joint graphics. Even in the earlier version, we were able to see the expansion joint, but now what they have done over here is, with the help of the graphics only, I can able to come to know that we have applied the 4 convolutions. That is, 1 convolution is equal to 2. So you can able to know that yeah, there are 8 convolutions in this expansion joint. Okay, so the graphics has been improved. I can read from here itself. Instead of opening the expansion joint data and just going to check, I can able to see it from here itself. Then you can see the circumferential weld line again over here is visible to you. Then the next productivity is the shell band graphics. Okay, so you know that shell band is a thickened portion of a tube which is adjacent to the tube sheet. So earlier when we used to model a shell band, it was looking like the same what the shell diameter is. But now you can see the shell band is a thickened portion. Okay, so they have improved the graphics. So now you can able to see the shell band in the 3D model, and you can see the edges also clearly. Okay. Then the next productivity is the forces and moment symbol on the nozzle. So this is just a symbolic representation. I mean, this doesn't have any connection with the design. This just indicates that this is the nozzle where we have applied the local stress analysis. Okay. So what happened in the earlier, we have applied the local stress analysis on few nozzles, but after some days, I mean, we are not aware, and we used to click on each and every nozzle and we used to check whether we have applied the local stress analysis to this nozzle or this. So we used to go and check to each and every nozzles. But now with by seeing the 3D model itself, you can figure out that this is the nozzle where the local stress analysis has been applied. So we are doing the WRC calculation for this nozzle. So this is just a graphical representation. Then the next is, now you can see the hole in the skirt itself. Of course, even in the earlier version, PV Elliott was doing the area opening skirt opening calculation. But client used to tell us that whether the PV Elliott is doing or not. But that time it was just a graphical problem. If in the earlier version also PV Elliott was doing it, but we were not able to see the hole in the skirt. So now they have improved the graphics. Now you can able to see the hole in the skirt also. Then the next productivity is the knuckle and flare is shown in the graphics now. When we used to model a cone in till 2015, it was just a straight cone actually. But now from 2016 version, you can give the knuckle radius and flare, all those things. So the knuckle and flare portion can be easily seen in the graphics. For both the case, you can see the knuckle and the flare portion is visible into the graphics. So they have updated that also. Then the next productivity is the color coding display. This is just a legend which was there in the earlier version also, but it is just that since they have added a repad in this version, so you can able to figure out that this is the nozzle with the repad who is having the material SA516 grade 65, and this is the nozzle with the repad whose material is SA516 grade 70. So that is the only addition they have made it. Okay, rest everything was there in the earlier version also. Then the next productivity is the, you can see till 2015 we were having only these two options, the heading text and the title page text. So now they have added one new information, that is the drawing and revision information. Now you can give the reference number, the revision number, client name, drawing number and the contract date. So whatever informations you feed it over here, it will be get updated in my report also. So you don't need to rename your job file that this is the revision A file, revision B file. I mean, you can directly update it into the software, and you can, while viewing the report, you can come to know that this is the revision 2 file. Okay. And you can also type the contract date, the drawing number and the client name also. So this will be visible in your report. Okay. Then the next productivity is now you can able to see the creep range materials. Like actually what happened in the earlier version, you might have noticed that PVL used to highlight the G5 materials, which was in the blue font. So when we used to select the materials, when we click on color G5 materials, so all the higher strength materials are getting highlighted and listed below. Okay, so that you can able to see. But now what happened if the material is under the creep range? Let's say you have selected the SA516 grade 70 material whose the temperature is 800°F. So this is the material which is under the creep range. So it will highlight in your report also that the material is under the creep range. In the earlier version, so though the material was under the creep range, PVL never used to tell that this material is under the creep range. So this was again from customer side, it came to us that a client is asking for such things that it should be highlighted in the report. So we updated this. So now you can able to see when that material crossing the creep range area. So in the report also you can able to see that this is the material which is under the creep range. Okay. Then the next productivity is the quick tower modeling. I don't know how many people are using this, but this is very good feature. What we have done here is we have updated PVLit to allow you to calculate the effective wind diameter using only a few inputs. So if you see the new special effective wind diameter dialog will contain very few inputs that will allow you to easily calculate the wind diameter for a vertical column, which will make it quicker to determine the foundation load which is necessary for the structure. So what exactly we are doing it over here, it is just that you are artificially increasing the diameter by using this equation so that you will get higher wind loads in the bending moment, and so with this you can get the estimate on the foundation. So you know that how much it will going to cost and all, so that you can take care of that actually. So actually what happened, this feature right here goes hand in hand with the next one if you see over here. Okay, so what exactly over here, this is in the weight percent inclusion dialog box. Okay, this is basically for the bidding stage actually. So you can use this quick vessel modeling option. So what here, I just have to build a model. I don't have to build the platforms, the ladders, the nozzles, etc. Instead of this, what I'll do, I will just add this miscellaneous weight. Okay, I will add this miscellaneous weight so that it will give me the estimation result with respect to the same. So based on this, we can submit the report for the bidding stage. So this feature was there earlier, but now what we did, what we updated over here. So we added piping over here, and then if you see in the bottom we added one more column, that is there a top head platform. So if there is a top head platform, then you can give the top head platform unit weight, circular platform weight, and the ladder weight. So all this information you can provide it and you can get the result for the same. Then one more thing what we added over here is, if you see over here, earlier we were having only two tabs. If you just go through that dialog box, you will get it in the loads dialog box, where in the miscellaneous weight percentage option. So just go through and check it. In the earlier version we were having only two tabs. So now we have added, now you can add the percentages to increase the weight of shell and heads. So what, by giving this information, I mean with the help of this feature you can build even more faster. So this is very a good and handy feature actually, I mean basically for the estimation stage. Okay, so this was all about the productivity enhancements. So let's move on to the next part, that is the code update. So if you see, this is just a mandatory code update over here. So we have added the section 8 2015 code has been added in the 2016 version of the PVL software. So in division 1 update, the update happened in the UHX, that is the minimum operating pressure. So earlier we were having the option to put only the max operating pressure. So what happened is, software used to do a lot of iteration to get the results. So now they added minimum and maximum operating pressure in the UHX. So if you input both the information, it cuts down the total number of cases that you have to run actually. So before you may be getting 3 to 4 case combinations. So having this will cut down, or you can say it will reduce your load cases actually. So this is again a pretty good feature they have added. Okay. Then for the nozzle reinforcement, welded pipe higher allowable. So you know when you have welded pipe or a tube, the allowable stress according to section 2 part D, they were like 85% of what could be used for the reinforcement. So like if you have a welded pipe or a tube, when you run the nozzle reinforcement calculation, the allowables were automatically divided by 0.85, and that stress allowables will be used in the calculation. So because of that higher allowable stress, area opening calculation was getting reduced. So you can get a little less area required and a little more area available. So you can say by increasing the allowable stress, I mean it will help you to reduce the nozzle thicknesses. So this was the update they made it in this 2015 code. Then Appendix 26, that also got updated. Some wordings got changed, some formulas got updated. So this also got updated in the software. Then the next is, if you see, that is the division 2 point of view. So division 2 doesn't have much changes actually, only errata fixes mainly. Like they fixed an issue which was regarding the hoop stress value. So previously software did not consider the hoop stress due to hydrotest pressure for calculation as per the division 2 PD 5500 and UN 13445. So for all this course it was not considering the hoop stress for the hydrotest pressure. Okay, so now they fixed this issue. So now it is considering the hoop stress and it calculates a non-zero stress value. So there are such kind of fixes have been updated, has been resolved in the division 2 code. Similarly, same in the division 1 code also there were, I mean obviously some problems were there in the earlier version. So they fixed few of them. And few of them are still pending and they are working on it, and it will get updated in the near future versions. Then coming to the section 2 part D materials, over here they have done a major changes, like there were hundreds of material changes. They fixed the existing materials and they added some new materials. So this includes the imperial tables, the metric tables from both section 8 division 1 and 2, and the yield stress tables. Okay. Then coming to PD 5500, there were some cosmetic changes to 5500, no more calculation changes, only they fixed some issues. Okay, same in the EN 13445, they now included in chapter 22, which is on the combined loadings. Okay, so some other code updates such as the IBC 2015, they have updated. They have added this IBC 2015. Earlier we were having only the IBC 2012, which which we used to calculate the structural height actually. So in the earlier, what happened in the IBC 2012, you might have noticed that there was a bug where software was incorrectly calculating the structural height of certain vessels, mainly for IBC 2012, that is the earthquake calculation. So previously what happened when a vessel had a multiple cylinder with a sump head in the first cylinder, the software used to calculate the structural height only up to the sump head actually. So it was not calculating the overall, it was only calculating up to the sump head. So now it has been updated and now the software calculates the structural height for the entire length of the vessel. So that has been updated in IBC 2012. Okay. So that was a bug which got fixed in this version. So then they updated the B16.5 for flanges. They updated all those codes, and Mexican wind and seismic codes have been updated. Okay, so all those changes have been done over here. Then that was all about the codes. Now coming to the interfacing. So PVLIT now exports to a VUE file format. What I mean, you can create a PVLIT model, and with the help of that VUE file exporter, you can export the file, and you can send that file will be extension name will be .vue, and you can send this file to the SmartPlan 3D or SmartPlan people guys, so that they can import that into the SmartPlan 3D environment or SmartPlan review for reviewing purposes. Okay, so SmartPlan 3D is a 3D modeling software which many of them might be aware, like where you can model greenfield, brownfield projects similar to the CAD works. So it is the same. So you can import the PVLIT model to SmartPlan 3D environments package. So in the near future version, I mean, there will be a facility where you can take, where there is a, the person who are using SmartPlan 3D and PVLIT software. So obviously they have modeled a vessel or an exchanger in SmartPlan 3D environment. They can take that vessel, they can import that vessel into PVLA, so that you will save your time and you can directly spend your time on the analysis point of view. So currently there is only a single way interface. In the future version, there will be having a bi-directional interface. Okay. Then the next point is the analysis. What they have done is they have updated PVLIT by adding an hydrotest, additional hydrotest option for ASME Division 1. So the new appendix to 27-4 option was added to hydrotest type, which is on the design constraint tab. When we select the UG19 and B19 and C, all those columns, in that column itself, they have added one new column, that is the appendix 2744. 27-4. This new option will allow you to test the glass line vessel which will meet the requirement of appendix 27-4 of ASME division 1. Okay. Then the next, if you see over here, this was actually a bug in the earlier version. Like while doing the base ring design, when we used to select the base ring design option as Brownell and Young design or Brownell and Young analysis. Okay, so two options was there. So when we used to select, it was automatically not taking to the neutral axis shift method. Though the software doing the calculation as per the neutral axis method only, but it was taking some other option which is there earlier. So now the software will analyze according to neutral axis method only. So they have updated that. So whenever you are going to select the Brownell and Young design and analysis method, it will directly take the method for thickness calculation as neutral axis. Okay. Then the next point, if you see, is this was related again. This was a query came from some of the customer that when we used to model a vessel with the jacket and the legs are attached welded to the jacket. So what earlier software used to do is software uh, used to take the diameter of the shell when we used to perform the WRC 107 for lag calculations. So now they have updated that. Now the software will use the diameter of the jacket when performing the 107 leg calculation. So they have updated this in the 2016 version. Okay. Then the next is the output generation report. If you see over here, this is just a first step. Now you can have a dark heading table. You can give the color theme for this. You can change the color theme from blue to white or any other color, and you can make some changes. If I just go on to the next slide, if you see, now the reports are printed in a tabular format. Okay, so you can give the table heading color or the table body color. So all those things you can do it over here. Okay, so this was the changes what they have made in the output generation report. So let's move on to the software. I'll show you that how to model an appendix to flange in PVLE 2016. Okay. So what I'll do, I'll just open a sample model. Okay. So this is just a demo example. Okay. If you see over here now, you can able to see the circumferential weld line. So by seeing the 3D model itself, I can figure out that this is the shell number 1 and this is my shell number 2. Okay. Same thing, the edges of the weld line is also clearly visible to you now. Okay. So now let's say I want to attach a nozzle on my shell number 1. So I'll select this and I'll attach a nozzle over here. And I'll name this is my nozzle N1. And this is a 6-inch nozzle with the schedule 80. Okay. And I'll add a repad over here. And then I'll just click OK. Okay. I'll give some height, the shell height, that is 3 feet. Okay. So you can see over here the repad graphics is clearly visible to you now. So you can see the repad in the 3D model. So now let's say if I want to model an appendix 2 flange over here. So how you can do it? So I'll just click on the nozzle dialog box. I'll just make this flange as none since I want to design the flange as per my requirement. So I'll just make it as none and I'll select OK. So now this is just a nozzle neck over here. Okay, I'll go to the last element. Then I'll select the flange. So just ignore the figure right now because over here it is, you can see that the flange appeared over here on top of the dish. So I'll name this is my well neck flange. Okay. And I'll scroll down. I'll just click on perform flange calculation. I'll just click as a standard flange, 6-inch. Okay. So you can design a non-standard also. Okay, and I'll click it OK. I'll scroll down again. I'll just click check this sump head button. Okay, I'll click this button and I'll connect my flange to a parent nozzle, that is the nozzle N1. So the moment I've clicked nozzle N1, my flange got attached to this. Okay, the similar way if I want to attach a blind flange or meeting flange, you can say, to the well neck flange. So again I have to go to the last element. I'll be selecting the flange, then I'll rename this as a blind flange. Okay, I'll go to perform flange calculation. I'll check this as a blind flange, obtain dimensions. Okay, then again I'll check the sump head button. I'll click on parent nozzle. Okay, so this way I can have modeled the blind flange to the nozzle. Okay, now if I want to attach a nozzle to the blind flange, so simply I'll click the blind flange. Now you can see the nozzle tab is visible. So earlier it was not visible when it was just a standard nozzle with the flange. Since the flange was not having a node number, so now we have designed the appendix to flange as per the node numbers. So now I can able to model a nozzle onto that flange. Okay, so the moment I click nozzle over here, I can directly select a 2-inch nozzle or whatever. Okay, so this is the way like you can model a nozzle to that blind flange. Okay, so let's say if I want to run this file and I want to see the tabular report which we have seen in the PPT. Okay, so I'll just run this file. Okay, so if I want to generate a report and so I'll just click over here and I'll see whether my report are coming in a tabular format or not. Okay, so I'll print to PDF. I've selected very few so that the report gets generated as soon. So now you can see the reports are coming into the tabular format. Okay, so element thickness, pressure, everything in tabular format too, so that you can able to see it. Okay, so this is very nice feature they have updated in this version. Also, you can see over here like you can change this intergraph from earlier when we used to generate a report. The intergraph name automatically appears over here. So you can change that to your company template also. Okay, so this is what if you have seen over here in the file. When I select preview print, there is edit header option. Okay, so the moment I click on edit header, I can randomly change that logo and I can pick my company logos as I have made it that I have kept over here the image graphics logo. So same thing you can also do it and you can save the file. So then it will reflect in your report also. Okay. So anyways, we are running out of time. So all right. So time for question and answer session. So let me just go on and click on the questions and see do I have any questions to answer. Okay. So I have one question that how to create elbows or T's. Sorry to say that, but we cannot create elbow or T into PVLit software. So that is the additional product. I mean, you can model the T's and the elbows in the Caesar 2. It's a pipe stress analysis product where you can model those things. But of course, like when you have a nozzle with the pipe, uh, which is in the bottom, so you can model the little bit of piping into it. So over there the bend will going to appear, but T you cannot able to model it in the PVLE. Okay, one more question from the other. When are you going to present updates in the tank software? uh, Soon we are going to do the presentation. We have already lined up the webinars. Okay, so the tank update are going to appear come in the in the January end. Okay, so we are planning to have a webinar for the same. Okay, another question I have over here. I have one more question that what about unknown data? It can assume or not. Sorry, I didn't understood your question. uh, if you want you can mail to me and I will address your query. Okay, yeah, another question is you said we can put nozzle on the blind flange. Can we apply nozzle loadings on that? Yes, of course you can apply nozzle loadings onto that. So that is the same common procedure, okay, what we used to do it earlier. So you can apply the nozzle loadings onto that also. Another question is there was bug in 2015 which was not in earlier version 2013. What about 2016? But can you please elaborate which bug you are talking about? Okay, another question is when we analyze 2015 file, it gets hanged. Is it resolved in 2016? Actually, this is a problem with the actually interface, the graphic interface and the resolution of your screen actually. So it is just that when you run your file, it might be showing you not responding for a few seconds, but suddenly it runs the file. Same is happening in 2016 also, but it all depends on machine configuration. Okay, so few machines are not facing such problems. Maybe the resolutions are not getting matched with the PV Elite graphics, so that might be the reason. Okay, so is there any plan to add rectangular nozzle to cylindrical shell like weld pad type level gauge? Currently, there is no such planned. Intergraph has made any planning, but don't know. I need to check again with the developers whether they have already planned for such kind of things or not. But till date, as per my knowledge, they have not yet planned for the rectangular nozzle on the cylindrical shell. Okay, so I think I have addressed most of the queries. If you have any queries, you can feel free to email me. My email address already. I'll be sharing it with you. Okay. So thanks for joining this webinar, and there are few more webinars, as I said, on PV Elite and some other products which are already lined up. So we will be keeping you posted on the same. However, I would be happy to receive any comments or emails on this for any further more queries. Okay. So I'm just winding up this session for today. Thanks once again for attending. Thank you.